Hey Earth Science Explorers, welcome back to another session of 3D questions from STEAMspirations. I'm Mr. Lara, and today we're going to embark on an in-depth exploration of the processes that transform loose sediments into solid, enduring sedimentary rocks. This transformation takes many years, with each step playing a vital role in shaping the Earth's surface. So let's jump into today's activity. Imagine you're a geologist trying to piece together the puzzle of sedimentary rock formation. Your challenge is to match these descriptions with the correct process names, helping you understand how these forces work together to create the rocks we find on Earth. First, let's thoroughly explore each stage without naming them. Stage 1. Picture a massive ancient mountain range standing tall against the elements. Over countless years, various forces begin to break down the solid rocks into smaller particles. Imagine how the relentless action of wind, water, freezing temperatures, and even plant roots can slowly but steadily wear down these rocks. This stage is essential because it provides the raw material, the sediments, that will eventually form sedimentary rocks. Think about what happens to rocks when they're exposed to natural elements over long periods. This stage is all about breaking down something big into much smaller parts. Stage 2. Once the rocks have been broken down into smaller fragments, these particles don't just stay where they are. Natural forces come into play, transporting these sediments from one place to another. Picture a river in full flow, carrying sand, silt, and pebbles downstream. Or imagine how wind can pick up fine grains of sand and move them across a desert. This stage is all about movement, getting the sediments from where they started to a new location. Quick tip, consider how rivers, glaciers, and even wind might move these particles. This stage is focused on the journey these sediments take after they're formed. Stage 3. As the sediments are carried by these natural forces, there comes a point where they settle down. This settling typically happens when the energy that's been moving them decreases, like when a fast-moving river flows into a calm lake or ocean, causing the sediments to sink and accumulate on the bottom. Over time, more and more layers of sediments are laid down, building up over long periods. This stage is crucial for forming the distinct layers we often see in sedimentary rocks. Quick tip, think about what happens when particles that are being carried away by water or wind finally settle down. This stage is all about laying down the foundation for the rock layers that will form over time. Stage 4. As layers of sediments continue to build up, the weight of the upper layers begin to press down on the layers below. This pressure squeezes the particles together, making them more compact and dense. Imagine pressing down on wet sand with your hand. Notice how the sand becomes firmer as it is compressed? Over millions of years, this natural pressure compacts the sediments so tightly that they lose any gaps between particles, pushing out water and air. Quick tip, reflect on how pressure might affect layers of sediments over time. This stage is about the squeezing and tightening that turns loose sediments into something more solid. Stage 5. In this final stage, the compacted sediments are transformed into solid rock. This happens when minerals dissolved in water move through the compacted layers, acting like a glue that binds these particles together. This process is slow and gradual, but it's what ultimately turns the compacted sediments into solid sedimentary rocks. It's the last step in the journey from loose particles to rock that can last for millions of years. Quick tip, consider how minerals might work like glue, sticking the particles together. This stage is about solidifying the layers into a durable, cohesive rock. Now that we've explored each stage in detail, it's your turn to make the connections. Your task is to match each of these stages with one of the following processes: weathering, erosion, deposition, compaction, and cementation. As you think about each description, consider how it aligns with the process it represents. Use the tips provided to guide your decisions. The following are guiding questions to help you. What natural forces are involved in breaking down rocks into smaller pieces? Think about the elements that constantly wear away at the Earth's surface. How do these broken pieces move from one place to another? Consider the role of rivers, wind, and glaciers in transporting sediments. What happens when these particles finally settle in a new location? Reflect on how sediments build up layer by layer over time. How might pressure affect these layers after they've been deposited? Imagine the weight of countless layers pressing down on the sediments below. What process could turn these compacted layers into solid rock? Think about how minerals might act to bind the sediments together. Reflect on these insights as you work. How does each process contribute to the formation of sedimentary rocks? Can you see the importance of each step in creating the layered structures of sedimentary rocks that we observe today? What stories do these layers tell us about the Earth's past environments and geological history? These are main concepts to remember. The transformation of rocks into sedimentary layers involves breaking down, moving, settling, squeezing, and finally solidifying. Each process is a crucial part of a larger story that shapes the Earth's surface over vast periods. Understanding these processes helps us appreciate the dynamic nature of our planet and the forces that continue to shape it. As you complete this matching activity, make sure to document your thoughts and observations in your Level Up workbook. This exercise is not just about matching terms, it's about understanding the powerful geological processes that have shaped our planet over many years. By exploring these concepts in detail, you're building a solid foundation for future studies in earth science. Keep joining us for more exciting sessions in 3D Questions from STEAMspirations, where we'll continue to unlock the secrets of our dynamic planet together. Happy exploring!